Okay, so today we are going to do a quick review of the stuff we have learned in the last week or so. We had two items. One was graphing and the other one was identities. We practiced graphing quite a bit. Let me just make a list of identities and make a suggestion how to get yourself ready for the test. And then also we pick up questions and do from either group. So we have identities and graphs. The identities that we looked at recently came in a variety of groups. We had a bunch of so-called basic identities. They formed the so-called reciprocal identities. For example, sine of x is a reciprocal of which function? Cosecant of x. Each function is a reciprocal of somebody else, so you have 6 of these. Then we had the ratio identities. Ratio identities tell us some functions are ratios of some other functions. Most famous of these things are just 2 of them. Tangent of the x was ratio of 2 functions. What were they? Sine of x over cosine of x. So 6 total here. At least 2 we had here. We had negative angle identities. For example, sine of minus x, if negative of an angle is given, how can you rewrite it in terms of the angle itself? What happens to that negative sign? In the case of sine, it survives, comes out. You remember we had 6 of these. Then we had okay, so these were so-called basic identities. We had then Pythagorean identities. Most famous form of this thing, of course, has to do with a triangle where the hypotenuse is 1, the angle is theta, so the opposite of it is sine, and the adjacent is cosine. Pythagorean theorem in geometry says sum of squares of the legs is the square of the hypotenuse. So you get sine square of theta plus cosine square of theta is equal to 1. Remember that, so we had different forms for this. So there were at least 3 of these guys. Meaning you can take this to be 1, and then you can take this one to be 1. So what do you do? If say this side is 1, what is the opposite? And what's the hypotenuse? Opposite, ratio of opposite to the adjacent has to be what function of theta? That was tangent of theta. Ratio of hypotenuse to the adjacent, what is that one? Secant of theta. So what's the identity between these 3 elements? Sum of the square of the legs, 1 plus tan square, is equal to what? Secant square. Here this becomes cotangent and this becomes cosecant. So cotangent square of theta plus 1 is cosecant square of theta. So Pythagorean, we had 3 of these, together with the fact that each of them spawns 2 others, depending on what you take to the other side. But then we are not listing them. So remember, for example, cosecant squared minus cotangent squared is 1, or secant squared minus tan squared is 1. But you have to kind of bring yourself to this picture and do whatever is needed. So Pythagorean identities, you need these. Well, where are we headed with these things? Of course, you go ahead and make a list of all of these things on several pieces of papers. And I suggest you make it in the form of a table. Your table, just write the left-hand side Okay, so this is going to be one piece of paper, and then you pick another piece of paper. On this one, you practice the right hand side. You make a list of all of these things from memory and come back, see which ones you have missed, read through that section, make sure you understand where the identity itself comes from, practice some problems related to that, then get another fresh piece of paper, go through this thing again, go through this thing several rounds until you hit it better than 90%. Then you have some readiness for the test. So this is for this section, and the identities are going to be worth a substantial portion of the test coming up on Monday. So we had Pythagorean. What else we had? Then yesterday we had a bunch of new ones. We had sum and difference. So how many of these things we had? Depending how you write. So for example, this was the origin of all the discussion, cosine of alpha minus beta. So you make sure you get this thing right. When it comes to identities, there isn't much of partial credit one can go with. That's like a basic block. If it is wrong, then it's just wrong. There is nothing you can do after that. So when I say 90% right, means 90% exactly duplicated the way it's supposed to be. And once you go through that exercise of starting from the left, matching it to the right, then your next level is to have the right hand side and try to remember where it comes from the left hand side. That makes more sense in the context of an exercise like or an identity like this. When you see that, you should remember this. Okay, that's the second level. Most often the students learn to go this direction. When they see this, hopefully they remember that. Higher level up, when you do simplification, you want to be able to go from this side back to that side. So on another piece of paper, you write the right hand side of these major identities to get a rearrangement of these things. Make sure you can recover the original one. So we had for the sum and the difference. So you had cosine of alpha plus beta. Of course, if you have learned all the tricks I taught you and all the other identities, you wouldn't need to memorize so many things. But first time around that you go through such courses, it's better to do as much of an exercise as you can so that the form of these things stays in your mind and hopefully it's still there in a year or two. So you have sine, cosine, tangent. You handle all of these functions. Yes? But the other three comes for free. Like if you have sine of negative being minus sine of x, then what is cosecant of negative of x? Since cosecant is just a reciprocal of a sine, you don't really need to memorize that all over again. So the book just stays with that, and so on. So we have 6 functions. We have 6 negative angle identities every now and then. The book summarizes just the primary ones and leaves the other one to exercises and such, but there are really 6. What else? We had double angle. Double angle are just child of these, not for the negative, which is going to be an identity. If alpha and beta were equal, this is going to be 0. Cosine of 0 is 1. On the right hand side, all you get is cosine square plus sine square, which is just a Pythagorean identity. Double angle refers to this case, where angles are the same, like alpha and beta are the same, so each of them is a theta. Then we had cosine square of theta minus sine square of theta. And we have this double angle some of these double angle identities come in multiple formats. For example, this has another style, and then again, if that wasn't enough, a third style. You need to know all three of them, and more importantly, again, you need to remember, once you see that, you should remember the left hand side of this expression. When you see that, you should remember that, and so on. For sine of 2 theta, our life was easier. What was sine of 2 theta? Theta cosine. So from now until Monday, you probably need to repeat this thing to yourself a couple of dozen times, going through that list. You have to blacken a whole notebook, practicing this over and over again until it stays in your mind. Tangent of 2 theta, what is that? 2 tangent of theta minus tangent square of theta. Okay, we had a bunch of double angle identities. Taking these equations, turning them around, give you half angle identities. Half angle, for example, if you aim at that one, you get cosine of theta. I take the 1 to the other side, 1 plus cosine of 2 theta over 2, which sometimes in the text this might show up like this: cosine of x
on the homework, very rarely did they show up in the x over 2 format. They showed up in a degree format.
Either way, either this one or that one could be solved as half angle formulas. Just remember, this is half of that. Same way, this is half of that, and so on. And then we had, if you start from this one, sine square of theta, I do the same rearrangement, or sine of x over 2 is a plus or minus 1 minus cosine of x over 2. What else? Then you had tangent square of theta. That doesn't come from here, rather it comes from the ratio of these two. To make it explicit that we really have half angle, remember that these signs are independent from those, so when you take a ratio, there is still a plus or minus. Just like cosine had 3 reincarnation here, tangent has 3 of them here. One of them was sine of x over 1 plus cosine of x. The other one is that right? So we had a whole list of these things. So again, you make a listing on the left. I don't want to write the right hand side and cover it up, or co-function identities. Those are they are probably the easiest ones. Co-function identities, we can have 6 of it. Simply stated, co-function of complementary angles are equal. So cosine of x is sine of what? And there are some other identities listed under similar heading. Depending on what you do here, we did some exercises. You can cook up some other identities, but they are not as fundamental as what we did. So, okay. Now let's do since we mentioned all these identities, let's do a little bit of a practice on them, just so that we have something on our plate other than the identity itself. Some of these things, for example, problem 53, it says use sum and difference identities to figure out an expression for tangent of 105. This is 113, section 2.1. So it says, the heading says use sum and difference identities to find the value for this. So let's be clear that we don't mean just type in 105 on your calculator and give me that and say okay. So much of the exercises in this section, calculator doesn't play a role. If anything you have to do, you do everything, you show all the work. If you have to use a calculator, that is the very last step, typically the not so significant step of it. At any rate, the idea here is to take 105, break it up into two pieces, either as a sum or difference of angles that you are comfortable working with. So we think about 105. Who are we comfortable with? We are comfortable with 30, 45, 60, and of course you can handle 90, 180, and so on. These are building block of much of things that we are doing. So 105 can be written as what? So that's how we approach it. So okay, this is tangent of 60 plus 45, which is tangent of 60 plus tangent of 45. What else should I do? Divide by, minus. Now, as we said, in this course we are just focusing on these things, but you need to know tangent of 60 from the first test. Tangent of 60, how we figured that out. So okay, this is 30, this is 60. Tangent of 60, opposite to adjacent, that's radical 3. 45, our trick to memorize the situation with 45 was this. Tangent of 45 is just 1. Denominator, I have radical 3 times 1 again, so it boils down to radical 3 plus 1 over 1 minus radical 3. So by now we have 75% of the problem done. After this comes the following. Simplify. So at that stage, or this stage, using calculator is not the intention of this problem. We are just practicing algebra and trick, not calculator. So what do we do next? So okay, simplification here, the only thing that we can think of is rationalization. So what do we do? Conjugate of a denominator. Conjugate means change the sign from negative to positive. So I'm multiplying by the conjugate of this, which accidentally happens to be what is in the numerator. That's just pure coincidence. Okay, these two are called conjugates. What is the claim to fame of conjugates? The claim to fame is that if you have sum and difference, you multiply them, you manage to square both terms. So if one of them had a radical, that gets wiped out by the squaring. That's where your simplification comes from. So we have this, we multiply by its conjugate. What we get is, you notice this is exact same as that, so you can use that in multiplication. In the denominator, I'll have square of the first minus square of the second. In numerator, I have radical 3 plus 1, and that same thing squared by accident. We have that form in the numerator. So I go ahead and in the denominator I'll have 1 minus 3. Numerator, I have several choices. I can leave it as it is. That is fine. I can go and clean it up. First item squared, that is 3. Second item squared, that is 1. Twice the first and second is 2 radical 3. Denominator, I have minus 2. So I have 4 plus 2 radical 3 over minus 2. Notice that I can factor a 2 from the numerator. And the whole thing boils down to 2's cancel, becomes minus 2 plus radical 3. So we did spend quite a bit of time cleaning this up. That is final answer. So from here to here, we were just going with trig. And then from here to here, we were doing algebra. Our final algebra term is, of course, a lot cleaner than what we had at that stage. So, don't forget, you take your angle, you break it up into angles you know about. You substitute, you remember your famous triangles, and then you